me start editing here as well, and we should be good to go. Alright, I had the mic muted, my bad. But yeah, I'm just gonna go ahead and start with this butt right here. I mean, this butt right here. So, I'm actually going to project sig, and then let me do a new directory. Just going to be, I don't know, say 64. Fuck it. Sig in it as well. Okay. Sig built. Sig run. Sig built run. Okay. I don't know why you have to put so much garbage in here, but sure thing, but say 64, say 64. What do you mean? What are you importing in here? Don't really get it, but for print, I'm just gonna get rid of you. Yes, and then I'm just gonna go ahead, build out sig, and the root source file is gonna be main. All right. So now I should be able to say again, sig build run. And doesn't work for what reason? std.debug dr was that should work. Okay, that does work. All right. I guess I can start it with this. As our first small project, I want to implement a base64 encoded decoded with you. Base64 is an encoding system which translates binary data to text. A big chunk of the web uses base64 to deliver binary data to systems that can only read text data. The most common example of a modern use case for base64 is essentially an email system like Gmail, Outlook, etc. Because email systems normally use the simple mail transfer protocol, which is a web protocol that supports only text data. So if you need for any reason to send a binary file, like for example a PDF or an Excel file, these binary files are normally converted to base64, which they are included in the SMTP message. Whoops, sorry about that. Alright, so hopefully you guys can hear me okay. But how does the algorithm behind the base64 encoding work? Let's discuss that first. I will explain the base64 scale, which is the 64 scale character scale that is the basis of the base64 encoding system. After that, I'll explain the algorithm. Okay, so we go into the scale, and then it's based on the scale that goes from 0 to 63, hence the name. Makes sense. Each index in the scale is represented by a character. So 64 characters in total. So in order to convert some binary data to the base64, I did not mean to do that. In coding, we need to convert each binary number to the corresponding character in this scale of 64 characters. The base 64 scale starts with all ASCII uppercase letters, which represents the first 75 indexes in this scale. Okay, so all ASCII uppercase letters, A to Z. So first 25, and then we have. Yo, Krishna, what's going on? What's SIG? It's a programming language similar to C, but with some modern features. That's all I can say about SIG. It's like a modern version of C, I guess. Okay. Range 26 to 51 at that scale. Alright, after that we have the 1-digit numbers 0 to 9, 52 to 61, and then what do we have? By character, plus, and respectively. Okay. Oh, never heard of. Yeah, I mean, it's pretty small at the moment. It doesn't even have a 1.0 version, so it's still in development. But at least for what I've tried so far, it's actually pretty fun. Not gonna lie. But yeah. I'm following this guide to learn SIG. Oh my god, thank you for that. To get a better understanding of SIG. I might have to lower this a little bit more. Okay. Back to here. Actually, how was this? Rename master to main. Okay. Git branch and master main. Alright. Great. There are 64 characters that compose the base 64 scale. The equine character is not part of the scale itself, but is a special character in the base 64 encoding system. This character is used solely as a suffix to mark the end of a character sequence or to mark the end of a minimal characters in the sequence. Okay, so the first one is uppercase, second is lowercase, then numbers, and then these two characters. Creating the scale as a lookup table. The best way to represent the scale in code is to represent it as a lookup table. Lookup table is classic strategy, so do I just have to... Okay. I don't know if I should keep everything in main or what, but... Alright, this is going to be a pointer of, yeah, I'm gonna say 64 U8. Variables must be initialized, so pub init, and this is going to return a base 64. Expecting function and variable declaration after pub. That's what you have, pretty much, right? Yeah. Oh. Okay. So then I have my const upper. It's going to be ABC. Oh, actually, let me just copy paste this. Shit. Expected function and variable declaration. Oh shoot. Yeah. Not bad. Lower, and then I can take all this and do this. Boom. There we go. Lower. And then const numbers, I guess. Okay, numbers and sims. And then it was... Okay, I just want to get the index right. There we go. Alright. To return base 64. self.table being, so I just have to make a concatenation for all these different things. Apple plus lower plus oops. And then this is what I have to do, right? I don't know why you're giving me trouble here. Const base64. Yikes. Yikes. Okay. Maya Robert, yo, what's up, dude? How you doing? How you doing? Sorry for not seeing the message. I didn't have the Twitch chat that accessible. How you doing, man? Are you there? Yeah. I'm there. Chill out. I'm right here. I just didn't have the chat right there. Thanks for the follow, by the way. Let's see if I can actually get the chat somewhat going in here. Okay. So I can now probably get rid of this, and then I can just have the chat in here. Boom. Okay. Alright. Okay, so now that I have all this, I need char add. So I basically pass the struct and then an index, and I just return the element at set index. Okay. So I just consider the pub. Yeah. Phone return char add. I'm just gonna say return char. Wait, but this is part of the struct as well. So this is a function within the struct. Okay. So this is going to be self base64. Sorry. There we go, and then a index, which is a usize. I guess what I have to return is a uint. So uint. And use function parameter yo chill. Okay. So what I need to do is probably yeah, just have to return self dot table return chart. Yeah, I mean I have to go into table and then yeah, the index. That's all I have to do, right? Okay, so could I do something like I don't know, print std.debug.print element at index 0 is going to be, because this is a chart, then it should be I could return char 0. Use a file declare identify return char. So I guess I would need to create a base64 basically. Right? Base 64. Hey yo. Okay, I deleted the entire thing. My bad. What are you doing? I am learning SIG, which is a programming language similar to C, but I guess with some modern features. But yeah, it's like a modern version of C, basically. That's what I'm doing, and I'm using this guide here to sort of get a better understanding of SIG. That's basically it. And then now the first project that I'm doing from this guide is building a base64 encoded decoder. That's it. So I guess I could say, I'm just gonna call you encoder. Probably this is not how you should be called, but rather something like bar encoder on the fly, or rather do I have to say init? Use a full clear identifier init. Can I say self dot in it? No. Okay. And then this should be. Let me change this here in live chat. Okay. And then this should be. Coder dot return char. Let's see if this works. Build run. All right. It does work. Hold on, I just got an email. What do you mean? All right, not relevant to me. All right. So now we have our lookup table and our struct. Okay, so you create your base64. Okay, so you don't necessarily need to specify the type in here because this already specifies it. Okay, so this would work as well. And you just call it base64, and you set it as a const. Interesting. Sorry, not const, but rather base64. All right. I mean, I guess it does make sense because I have already added all of the relevant values to it. Can I even do this? I don't think I can do this anymore with the current version of SIG. I mean, I'm sure I can do try std.debug. Actually, let me put this. And then base.char at, okay, 28. All right. This is basically what I have. Sig build run. Okay, why did you fail? Spectre error union type found void. What the actual fuck? So I guess I cannot try this anymore because you just return void. Yeah, you're just void. You do not return an error. Okay. Great. I don't think I even have flush anymore. Flush? No. So I don't know how to do that. Okay. The algorithm behind base64 encoding usually works on a window of 3 bytes. So 3 bytes for inch instead of 24 bits. But I guess its character is a byte in this case. You forgot the announcement. You could be correct. That I actually forgot the announcement. My bad. Okay. Let me actually get the link. Get the link and then announcement, I guess. I actually cannot type. Okay. There we go. Thank you for that. How are you? I guess is what you meant to say. I'm doing good. How would you? Okay. So because 24 is divisible by 6, which forms 4 groups of 6 bits each, therefore the base64 works by converting 3 bytes at a time into 4 characters from the base64. Right, please start sending me emails. Right. You will think that if you have there's not a visible thing. What happens, for example, if you have a string that contains only 2 characters bytes, such as I? How would the algorithm behave in such situation? You find the answer in figure. You can see that the string height becomes the string as gk equals. Okay. High, which then gets passed to the decimal representation of 72 and 105. This is the okay. So then you get divided in groups of 6 bits, and then X or zeros to fill the gap, and then you just leave the last field to null. Yo, what's going on? I just saw your message on Discord. I'm sorry about that, Espel, but yeah, good progress, man. I don't know what the fuck I did this night, but my neck is killing me. Anyway, this is one representation of the 6-bit. Okay, and then it gets transformed into this here. Okay, seems pretty straightforward. Not gonna lie. YouTube actually has never put you in my subscription feed. Wait, what do you mean by that? Like, do you not get a notification or what? Taking the string high as an example, we have 2 bytes or 16 bits in total, so we like a full byte to complete the window of 24 bits that the base64 algorithm likes to work on. So I guess we have to work at 3 bytes at a time. I guess it might be a little weird to handle that case. Like, I've got notification turned on, but I've never actually gotten one for when you go live. Should I maybe do that? I don't know if there's something that I have to... No, I don't want to exit this trip. I mean, I don't know if I have to change something where I have to notify or do something like that. Hold on, let me actually take a look. Edit. Make some represent bits to say, nope. It should just work. I mean, it should just work, actually, yeah. Embedded, I don't even know what that means. Who can send messages? Anyone? Message delay. Yeah, there's nothing in here. I mean, I guess it should just say it right away, right? But I don't know. I mean, the YouTube notification systems works however the fuck it wants. Like, sometimes it just doesn't work, sometimes it works perfectly. Like, I have no idea how that works. There's not complete, meaning that this groups of contains n bits for 0 and bits and 6. The algorithm simply adds X or zeros in this group to fill the space that it needs. That is why figure 4.1 in the third group after the 6-bit transformation, 2 X or zeros were added to fill the gap. Okay. I saw it as continue after video is finished. What? What do you mean? Okay. The fourth group is necessary because the algorithm works on 4 groups of 6 bits, but the input string does not have enough bytes to create. Okay, so wait a minute. So we do get this 4th group, which then gets translated into this character, which I guess is the way of saying we have finished the sequence. Because the other one, but the input string does not have enough bytes to create the 4th 6-bit group. It's empty. This group becomes a padding group. It's mapped to the character equal sign. Okay. Like your video came after a video finished in the ending. Okay. Okay, so that is the only way you get my videos? That's crazy. How's your progress? Pretty good, I'd say. I've actually been doing quite a lot of Siglings, which is a series of like basic SIG exercises. And then, I don't know, there's like 100 of them, and I've done 32 for now. But yeah. Okay. Back to here. Actually, let me do keyed at started, or actually I should call it first commit. Got the look up table stroke ready, and I can now push because I don't have a repo set up already. You liking it? I actually do like it. It's pretty fun. Not gonna lie. There are things that are still weird to me coming from C, but so far it's been nice. But yeah, maybe now that I'm going to start this sort of small project, I will find out more about the language. If you get the strings here, input the base64 encoded the strings translated into MA equals. Okay. The remaining two strings become padding grips. Okay. So this is the encoder, and then the decoder would be to, okay, you transform to binary, and then you group in groups of 8 bits, so in bytes, and then you get that, and then, okay. Seems pretty reasonable, to be honest. Okay, so if you don't have any previous experience with base64, you might not understand the differences between encode and decode. Yeah, I think I can skip this one. Calculating the size of the output. One task that we need to do is calculate how much space we need to reserve for the output, both the encoder and decoder. Okay, so this is actually an encoder, right? Yeah. So actually, I'm gonna call you encoder. I don't give a fuck. Encoder. Boom. Okay. The logic is the following. For each 3 bytes that we find in the input, 4 new bytes are created in the output. So we need to take the number of bytes in the input divided by 3, use the Hillen function, then we multiply the result by 4. Alright. Bit weird, but whatever. Okay. Alright, sorry about that. Also, you might have noticed that, okay, the calc encode length function below encapsulates this logic. Inside this function, we take the length of the input array, we divide it by 3 and apply a seal operation over the result by using the dipsealed function from the SIG standard library. Alright, so what is this? Study math dipseal. I was hoping to get the SIG version. SIG. Do I even get the math? Seal. This might be it. Actually, maybe not. So wait, is this asking for me to import? No, actually the math is inside of that. Okay, so dipseal should be in here maybe. Dipseal. Okay, built-in functions, sync functions, and topics. They should be somewhere around here. Dip exact, full return embed. Doesn't really look like it. Math. Yeah, probably not the best thing to look. Build noise. Well, I guess I gotta take the seal. Returns a smaller integral value, not less than the given floating point number. Point available. Okay. and apply a still operation over the result. So let's see if I can understand this. So yeah, we get an input, which is the array. I guess we get the length of the array. If it's less than 3, then we just simply return 4. Okay, so with the byte, and then input length and 3. std math dip seal. And why can I not get the actual 6 standard library? But this is not going to give me the math library. Memory, type primitives and grammar source encoding. SIG math library. I don't know if it's anywhere in here. No, this is actually an external library. Alright, fuck you. Well, okay. Let's see if I can. So I would have to do a pop function, which is calc, or actually output size. And we said that this is going to take a U8. Actually, it's still okay. Input, which is going to be a U8 array. Const U8. Okay. And this says that it can be a U size. Not really sure why the exclamation point in here, but sure. Okay, so if input.len is less than 3, then we just simply return 4, and then we have to do a const in groups, which is going to be a U size, and then we're just going to try std dot math dot dip seal. Hopefully this still works. So U size, it's the type U size. Limiter T is I think he said input.len, and then this is 3. Alright, so it looks like it works. And then we just have to, do I have to do return in groups times 4? Yeah. Let me actually, so you're learning by doing these exercises? Pretty much, yeah. That's what I'm doing. In SIG, what is the std.math.dip seal function? Performs integer division with rounding up. That means instead of truncating towards 0 like normal integer division, it ensures that the result is the smallest integer, the exact fractional quotient. Okay, so it just rounds up. Okay. That's all I wanted to know. Right. Now the logic to calculate the length of the output from the decoder is a little bit more complicated, but it is basically just inverse logic that we've used for the encoder. For each 4 bytes in the output, 3 bytes will be produced in the output of the decoder. However, this time we need to take the equal character into account, which is always ignored by the decoder. Section 4.1.4 and figure 4.2. In essence, we take the length of the input and divide it by 4, then we apply a floor function on the result. Okay. Then we multiply the result by 3, and then we subtract from the result how many times the character is found in the input. Okay. So let's see if I can more let's get this one. Cog input size, or wait, how do you call this? Encode length. Okay, I like that name. Cal encode length. Okay, and then this is going to be pub function calc decode length, which is going to take, I guess, another size, or actually no, it should get another input of characters. So this is going to be the same, const weight, and I guess you can actually be the same as well. Oh yeah, I know why. It's the exclamation point is because of this try, which could return error, and therefore will return error, etc, etc. Alright, my file manager, my file manager is almost can be used. It has all the sensitive features. Expect just remember it's basically moving a file. Yeah, I mean that's basically how renaming works in Linux. You just move a file from the, I guess, old name to the new name, but yeah. Good. When are you going to have it done, man? Do you have any sort of expected date? Okay, so let me see if I can encode length. Okay. In essence, we take the length of the input and divide it by 4. So I guess we can I guess say const. Well, I'm just gonna call you a variable, which I guess is going to be a usize, which is going to get the input.length and divided by 4. Alright. Division. That's what you're going to be called. We apply a floor function on the result. Right. So let me just call you result. And then we have to, could I do result equals a floor? std.math.dip floor, which is going to have a usize, a numerator t, which I guess is going to be the result, maybe, and the denominator is going to be 1. And then we'll multiply the result on the result. We take the result and multiply by 3. I'm just gonna sort of guess this here, but const. Right, and then we set in groups, so you're going to be const in groups as well. Alright, and then I guess I could say returning groups times 3, more or less. I want UI to be completed upcoming Friday. After that I can work on my own features that I add. Good. Alright, so let's see output length. So if input length is less than 4, then we simply return 3. Okay, I guess I missed that one. Okay, I guess I forgot. Try. Right. With the user the input length at 4. Sure. Okay. Sort of forgot this one. I forgot that last part. So if input that length is less than 4, we simply, what is going on with my keyboard? Okay, we return 3. Right. So how do you call this even? Oh, you actually don't do this at all. Okay. So this would be the input length. Whatever works for you, I guess. Alright. So back in this thing, I have to bar I use as input length minus 1. Okay, so const or bar multiple groups is results, sorry, n groups times 3. And then I have a bar I. Do I even have to specify? I do. U size. I want to make my Git contribution like your. I mean, I guess you just gotta do a little bit every day. That's it. Okay. So I guess it's going to be a U size as well, which is going to be the input.length -1. And use local variable. Okay, so I cannot do this. Alright, man. Alright. Okay, so while I is greater than 0, then do I have to do something? Okay, I do have, which is, what's it doing like this? I still don't get used to this whole thing. I -1, sorry, minus equals 1. There we go, and basically I have to say if, wait, U size should be a, yeah, okay. So if input I equals okay, then I just have to say, what do I have to say? Multiple groups minus equals 1. Okay. To me, what's crazy is the fact that I cannot do this. Like, the fuck? This is like the most basic thing in the world, and I cannot do it. Gotta be kidding me. Minus equals 1. Alright. Do I have an else? Break. Okay, so this has to be at the end, I guess. So if there's no equal character, then we break. Okay. Break. Let me actually explain that, because we start from the end. If there is no equal at first, we can break. We can get out of it. And then I just have to return multiple groups, right? Return multiple groups. That's what I have to do. Yeah. Okay. So multiple groups would be my, okay, because I don't need to actually, on the code, I don't need to take into account the equal signs. I need to take that back. Okay. So let me explain that here. On the decode, decode, I don't need to display the equal sign or take into account. Actually, I don't need to take into account the equal sign on the output, so I get rid of it. Alright, I added comments at first, then I started off explaining. I made my code a mess, then didn't wrote anything. I mean, honestly, you should only write comments. I mean, it's not like I'm an expert or anything, but I feel like you should only write comments on things that might not be understandable from the code itself. You know, like, the code should be pretty self-explanatory by just looking at it. But if there's something like, maybe for example here, like you might not really know what's going on, then just write a simple comment. You don't need to put multiple lines of code, unless the whole structure of the program is like really complex and you actually want to fully understand what's going on, so that if you maybe come back in like 6 months, you can take a look at the comment and then be like, okay, I remember this, which is something that I should actually do as well, but I just don't have the energy to do that. Alright, so in this section we can start building the logic behind the encode function, which will be responsible for encoding messages in this base64 encoding system. And you want to see now the full source code of the implementation. You can find in 6 examples. No, I think I can wait. The 6-bit transformation represented in figure 4.1 is the core part of this base64 encoded algorithm. Okay. In essence, the 6-bit transformation is made with the help of bitwise operators. Okay. So I guess these are the same as in C. Bit shift to the left and bitwise and are used. They are the core solution for the 6-bit transformation. Great. There are 3 different scenarios we need to take into account in this transformation. First is the perfect scenario where we have a perfect window of 3 bytes to work on. Good, I guess. Second, we have the scenario where we have a window of only 2 bytes to work with, and last we have, okay, with a single byte. In each of these 3 scenarios, the 6-bit transformation works a bit differently. It's actually 1 p.m. Wait, how much? Okay. Yeah, I get it, and it's very relatable. When I revisited my QR code to rewrite it in C# and make UI look good, I was mad because I couldn't understand a single thing, and now I have to understand it again. Yeah. That's like the best use cases for comments, basically. Works a bit differently. To make the explanation easier, I will use the variable output to refer to the bytes if the output So if we have the perfect window of 3 bytes, there are steps for the 6-bit transformation. Output 0 is produced by moving the bits from input 0 to positions to the right. Okay, so we shift this to the right. Output 1 is produced by summing 2 components. First, take the last 2 bits from input 0, then move them 4 positions to the left. And then second, move bits from input 1 4 positions to the right, sum these 2 components. I guess summing this would be an AND. Okay, so first operation I do have to shift, okay. No, I just simply sum them. Okay. Okay. Okay, let's see if I can actually understand this. So if we have the perfect window of 3 bytes, then okay. Output 0. Okay. So this is because we need 4 fields. Okay. Sure. So the first field is produced by moving the bits from input 0 to positions to the right. Okay. By summing 2 components, first we take second operation. But this is not really at like 2 positions to the right. Okay. So I only need to take into account the last 2 bits. Just like this shows, I only get the last 2 bits, shift them 4 positions to the right. But this is not really it. Okay. Two positions to the right. Output 1 is produced by summing 2 components. First, take the last 2 bits from input 0. Okay, the last 2 bits, okay. Get the last 2 bits. So we take the last 2 bits, then move them 4 positions to the left, okay. Move the bits from input 1 4 positions to the right, and then we sum this. Okay, so this picture explains this line. Output 2 is produced by summing 2 components. First, take the last 4 bits from input 1, so we turn the last 4 bits, then move them 2 positions to the left. Then second, move the bits from input 2 6 positions to the right, and then sum these 2 components, and then output 3 is produced by taking the last 6 bits from input 2. Okay, so this is the perfect scenario where we have a full window of 3 bytes to work on, just to make things as clear as possible. how the step 2 mentioned above works. I should have read that line. So the second byte in the output of the encode is made by taking the first byte and the second byte. You can see that at the end of the process we get a new byte that contains the last 2 bits from the first byte and the first 4 bits. Okay, yeah, and then 2 bytes that are just 2 bits that are just 0, because we work on fields of 6 bits. On the other hand, we must be prepared for the instances where we do not have the perfect window of 3 bytes. If you have a window of 2 bytes, then the steps 3 and 4, which produces the bytes output 2 and output 3, change a little bit. And they become output 2 is produced by taking the last 4 bits from input 1, then move them 2 positions to the left. So we take the last 4 bits. Okay, the last 4 bits, and then we move 2 to the right. Output 2. Okay. And then output 3 is the character equal sign. Sure thing. Alright, finally, if you have a window of a single byte, then steps 2 to 4, which produces the bytes output 1, 2, and 3, change becoming output 1 is produced by taking the last 2 bits from input 0. Again, then we move them 4 positions to the left. Okay. So we have 6 bits where it contains the, I guess, only the last 2 bits from input 0, and then the rest are zeros, I guess. Do you code all day? I do not code all day. I wish I could, but I cannot, unfortunately. Okay, output 2 and output 3. I don't code all day, but I code all days, if that makes sense. Okay. Output 2 and output 3 are the characters equal sign. Okay. If this bullet post are confusing, you may find the table 4.1 more intuitive. I don't really care. Okay, bit shifting in C works similar to bit shifting in C. Okay, if we take a string high, okay, are you just gonna give me an example of how to use a bit? Yeah. Okay, I don't think I need this with the AND operator. To produce the second and third bytes in the output, we need to select specific bits from the first and second bytes in the input string. But how can we do that? The answer relies on the bitwise AND operator. Yeah. So this is just going to be the same thing. I'll get in space for the output. I think I already had that, no? Okay. Turns out I don't. I have to go to the bathroom. Be back in a minute. Hold up. Alright, I'm back. Sorry, I didn't mean to activate that. Okay. What's your school time? I have to school, university, I started most of the days at 3:30, and then it could go from anywhere to, I don't know, I guess 7:30 to 9:30 in the or 9:30, I guess 9:30 is the way to say it. 9:30 in the night. So yeah, bit fucked up, but that's what it is. Allocated space for the output. Okay. We cannot know our compile time, which is the size of the output for both the encoder and decoder. Of course we don't. So if we can know the size of the output and compile time, this means that we cannot store the output for both the encoder and decoder in the stack. We need to store this output on the heap. As I commented in section 3.1, we can only store objects in the heap by using allocator objects. It needs to be an allocator object because we know for sure that at some point inside the body of this function, we need to allocate space on the heap to store the output of these functions. I get morning 9 to evening 4:30. God damn. That's tough. I mean, I still don't know if I prefer morning shift or I guess afternoon shift. I still don't know. I think I would rather stick with the afternoon shift, just because I don't have to like wake so early. But yeah, I still don't know. Okay. I have an argument called allocator, which is allocator object is input identified by the type std.mem allocator from the stick standard library. Alright, so you do received a standard allocator. Alright, so that's all I wanted to see. So let's just go ahead and do pop func code. Right, and then you're going to get a self. Well, actually self base64, so should you be inside of base64, allocator of type std.mem.allocator, and then anything else, the actual array, the actual input. Okay, input, which is going to be a const u8. Would that be const nope. God damn it. Fuck, I didn't mean to do that. So input, no, sorry. Allocator, which is going to be std.mem.allocator, and then the input, which is going to be const u8. And then the type is what? Okay. Alright. So I guess that's it. If input line equals 0, then we do have to say, so we just return this. Okay. I just want to see how you actually allocate that. Whoops. Okay, so const n out equals try collision and goal length. Okay, so this is what I already had, which is const would be, yeah, let's just say n out would be try collision code length, which pass the input. Do I have to do anything else? No, I just pass the input. Okay. Then I can say that bar out equals try allocator.alloc un with the actual size. Okay. It's going to be try allocator.alloc with a type of, I guess, usize, and then n out u8. Okay. Yeah, because it's an array. Okay. All right. And he does something like buffer, which is not really. So I guess this is for doing the fields or selecting like the 3 bytes at a time. So buff, it's going to equal to first the size. Okay. And then I can 0, 0, 0. Okay, we create, okay. 3 bytes at a time. I'm guessing count is 0, I out is 0. And then I out, which is going to be U8 as well, U64 equals 0. Okay. So I guess I now have to say for what I out input 0 to the end. Okay, this is a bit weird. So I guess now I go to the output and I have my whatever this is, which I don't really get. Then I have my I. So I need to say that path count equals input I. Okay, so I guess I need to count. Okay, so if it's 3, then I guess I need to reset the count as well. So path with count equals input I. Count plus equals 1, and then if count equals 3, then this means that we have our field of 3 bytes. So the first thing that I'm going to say is count equals 0. Alright, out IOT itself is the good dot self. Okay, so I first need to do this, right? If count equals 1. Okay, so this is basically as I, so I get my fields and then I do this. Alright. We have a field of 3 bytes. I'm just gonna say if count equals 2, and if count equals 1. And I'm gonna leave it for today because I gotta get ready for uni. Yay, great. Get yeah, whatever, man. Anyways, thank you for being here. To all of you, thank you, Darko, for being here. Yeah, I don't know if I'll be back after uni. I don't know if I'll do anything else, but yeah, thank you and see you guys tomorrow. Bye bye.